In this video, we'll talk about collection classes and interfaces in C#. They are, for the most part, like the Java ones, but sometimes with different names. Here are the commonly used collections in Java. These are interfaces like list, set, and map, and the classes implement the interfaces like ArrayList, HashSet, and HashMap. Using them is simple as long as you know what they are intended for. For example, if you want a collection in which the elements are ordered, you use a list. If you want a collection in which the elements are unordered but provides quick lookup, you use a set. And if you want something to store key-value pairs, you use a map. There are additional differences among different implementations of the same interface. For example, between ArrayList and linked list, or between HashSet and TreeSet, the difference is mainly about the computational complexity of different operations on the collection. Those are covered in data structure classes, so we won't go into details here. One thing about Java collections is that the elements must be objects, or in other words, they cannot be of primitive types like int. A concept closely related to collections is generics. The issue is that it's not trivial to create a collection class like an array list or a hash set. So we don't want to create one for integers and then create another one for strings and so on. We want to be able to create one collection class, then somehow use it to hold different types of data. One idea is to implement these collection classes as collections of objects. Because object is the superclass of everything, we can then use these collection classes to store everything. There are, however, two problems with this approach. First is performance. If we want to use these collections of objects to store primitive types in Java or value types in C#, they have to be converted into class types or reference types, known as boxing. When we take them out, we have to convert them back to the original type, known as unboxing. Boxing and unboxing are conceptually simple, but they still cause a performance problem if we have to do them again and again for lots of data. The second problem is type safety. Because the collections are for objects, any object may get in. For example, we may want to have a collection consist of just integers, but there's no way to prevent someone to put a string in there by accident. This is where generics come in. Generics allow us to create a class with one or more type parameter. We're familiar with parameters for methods. They are basically placeholders. When we try to call a method, we pass some actual values to the parameters. The same applies to type parameters in generics. They are again basically placeholders, but this time for types. When we want to instantiate a generic class like this, we just need to pass an actual type to it, like passing a value to a method. Generics give us a way to create a collection class for all data types and ensure that the elements in a collection is of the same type. Another nice thing is that the syntax for generics is the same in Java as in C#. So if you know Java generics, you already know C# generics. Okay, so what about collections in C#? This table shows the commonly used ones. If we compare this table with the Java one, we can see that they are mostly the same except for names. In Java, we probably use ArrayList the most often, and in C# is just list. C# actually also has an ArrayList, but is non-generic. The generic version, which will be used most often, is called just list. Another big name difference is map versus dictionary. In Java, the key-value pair collections are called maps, and in C# they are called dictionaries. And speaking of generics and non-generics, they are in different namespaces in C#. So when you import a namespace, make sure you import the right one, which usually should be the generic one, unless you want a non-generic connection for some special reason. In addition to the collection classes and interfaces we just saw, there are two more interfaces that are worth mentioning. Most of the collection classes in C# implement both of these interfaces. The IEnumerable interface lets us access the elements in the collection one by one using the for-each statement. And anything implement the iCollection interface has a count property, which is the total number of elements in the collection, and it also provides methods like add, remove, and contains. C# collections are mostly like Java ones, so we won't spend too much time on this. We'll do an example in the next video showing how to use list and dictionary. If you want more details, please check out Chapter 10 of the Pro C# Guidebook. This is the end of this video. Thanks and see you in the next one.